Today we're going to talk about Wazuh, and we have 4 items on the agenda. First, we're going to define Wazuh, and then we're going to list the use cases of Wazuh, the components, and lastly we will do some comparison. Okay, so what is Wazuh? Wazuh is a SIEM solution. As you know, guys, SIEM stands for Security Information and Event Management. So we're going here to put security. If you happen to forgot what is SIEM, and I for information, E for event, and M for management. So it's a solution that is used to manage events across the network. So basically, Wazuh can also be considered as an EDR. EDR stands for Endpoint, and D, detection, and the R stands for response. Well, so what does that mean? It means that Wazuh can act as SIEM and EDR. So both ways, Wazuh can first inspect logs, generate alerts. I don't know why it is writing like this, alerts. So by Wazuh inspecting the logs and generating alerts, it is acting as a SIEM solution. On the other hand, it can be considered as an EDR when Wazuh is actually monitoring the hosts on the network. Wazuh has this capability where it can be set to monitor the hosts on the network, the endpoints. So what it actually monitors? It monitors the changes on these hosts, the file changes, the system state changes, the changes done on the settings. It monitors for malicious activity. That's why we consider Wazuh as an endpoint detection and response. Now, previously I have covered Wazuh and how it is used as an endpoint detection and response. You can check out this video, Wazuh, HIDS, and EDR. I'm going to put the link in the video description. Now let's go back to the agenda here. So what are the use cases of Wazuh? Security monitoring. On a network level, right? So this means that Wazuh is not installed on a single device. It can be installed and deployed on all the endpoints on your network, which means it can perform security monitoring. The next thing it can do, it is vulnerability scanning. And yes, Wazuh can scan endpoints on your network. And the last thing, of course, these are some of the things. It is non-exhaustive list of the use cases that can be applied on Wazuh. The last thing that I'm going to mention is auditing. Yes, Wazuh can be used to audit your network for compliance with specific cybersecurity framework, such as maybe an IST. Okay, now having talked about the definition and the use cases, now most importantly, let's understand how Wazuh operates. So we have to talk about its components. So the first component is indexer. Does that ring a bell? We have actually mentioned this word when we talked about other SIEM solutions, such as Splunk. The other component is the Wazuh manager or server. The third component is the dashboard. And the last component is the agents. Let's talk about every single one of them. Okay, first one, the indexer. What is the job of Wazuh indexer? Much like in Splunk, The indexer's job is to store the collected logs. So you might be asking me, is Wazuh a solution that actually responsible of collecting logs? Yes. So how Wazuh can act as a SIEM solution? It needs to collect the logs from the devices it is integrated with and the endpoints it is set up to monitor. So when the logs are collected, events can be generated. Events can then be gathered, and based on the rules, alerts can be generated. So we need the logs. So the logs are stored in the indexer. The Wazuh server. The Wazuh server is the central component of the Wazuh solution. It is the server that's responsible for managing all aspects related to Wazuh, such as creating the indexer settings. We configure and create the indexer using the server. Creating the agents or managing agents, which we will talk about in a while. Creating what is called as decoders. I'm going to tell you guys what is decoders and the rules. Okay, the dashboard. The dashboard, this is the area of Wazuh where actually you have a GUI interface to manage all these aspects, plus to visualize data. If you ever wanted to create visualization or charts that depicts the data you have, the logs or the events, you can do that in the dashboard. And lastly, we have the agents. The agents are actually executables, okay, that can be deployed on endpoints. It can be Mac OS, you can deploy it on Linux, and you can deploy them on Windows. So why do we use the agents? The agents are responsible for, you know what, collecting logs. Collecting the logs from the workstations. And the logs are then sent, guess what? They are sent to the indexer, stored in the indexer, and then the Wazuh server will be responsible managing and generating the alerts, you know, processing the logs and generating alerts. Okay, let's circle back to one thing that we need to talk about, which is the decoders and the rules. What are the decoders and what are the rules? So, decoders and rules. We're gonna simplify the complex. So, decoders are a set of files, okay, that are responsible of, you know, extracting, but what? We extract the fields from the logs. Why is that? Because logs are different. You know, logs have different formats and they come from different devices, different operating systems. They might be coming from network devices. These logs have different formats. So in order to process and analyze the logs, we need a way to extract meaningful information, meaningful fields. Okay, so we extract the fields from the logs. Hence, this is the process called, in data analytics, it's called data parsing or processing, or you might call it processing. Processing data is the process of extracting meaningful insights, okay, or meaningful fields from the logs. That's what decoders are responsible of. Now, after the logs or after the fields, the meaningful fields are extracted. What's an example? Example is, let's say we have authentication logs coming from Linux. Okay, decoders, based on the decoders that are being used by Wazuh, they will extract information such as timestamp, IP address, MAC address, port, URL, so on and so forth. That's what's meant by fields. So extract these fields using the decoders. And of course, there is a way to create custom decoders using Wazuh documentation. By referring to Wazuh documentation, we can create custom decoders to extract specific fields if we have a unique log format. Now, the rules, much like in Splunk, the rules will actually process the extracted fields, okay, and based on the matching regular expressions used in the rules, we generate alerts. So the rules are files created with regular expressions to match for specific fields or specific values. If there is a match, we generate an alert. Okay, so that is how it all works. And the last thing is the comparison. Okay, so here let's take some examples. We have most prominently Splunk, and we have Wazuh. Okay, so the first thing, let's talk about SIEM, the concept of SIEM. They are both considered as SIEM. Wazuh can be used as SIEM and Splunk can be used as SIEM. Now, data analytics. Can Wazuh, or what about data analytics? Definitely Splunk can be used for data analytics. Wazuh partially can be used as data analytics, but if you want to use it fully for data analytics, you must combine it with plus Kibana and Elasticsearch. We have covered these subjects in previous videos. If you use Wazuh in conjunction with Kibana and Elasticsearch, you can use it for data analytics. Okay, integrations. So what do we mean by integrations? Integration is the way to use Wazuh or Splunk with other products such as Suricata IDS, Fortinet Firewall, VirusTotal, so on and so forth, to enhance your incident response capabilities. Both can be integrated with different IDSs and firewalls. For example, if you want to integrate Wazuh with maybe Fortinet Firewall, so with Fortinet Firewall. So what does that mean? It means we want to send the logs collected by Fortinet Firewall to Wazuh for processing and analysis. Definitely we can do that, and likewise in Splunk we can definitely do that. Now I'm not gonna go over this price comparison because it's a commercial subject. So that is for this part. The next part we're going to go over examples of using decoders and rules to process logs. So in this GitHub page we can find examples of decoders used by Wazuh. As you can see, they are all in XML and they cover wide range of different products from which you may want to ingest the logs. And on this page we have the rules. These rules come shipped with Wazuh when you first install it. They cover again wide range of products and log formats from which you may want to match or from which you want to generate the alerts. Okay, let's take an example decoder. Let's cover one that is common here. Scrolling up, let's take example Windows decoders. So this is an XML page. As you can see, it's a long list of decoders, but actually it can be broken down to different or individual components. So we have this one. We're not gonna talk about this one because it's short. Let's take this one. So it first starts with the tag decoder name, the name of the decoder. In this case, it is Windows Firewall. Let me make this bigger. Okay, right now it's better. So the name of this decoder is Windows Firewall. We can see the tag parent. So what does that mean? It means that this is a child decoder, and the parent of this child is Windows date format, which means the Windows date format is first used and processed before the current decoder. So first, Wazuh will process this decoder, to look for this decoder, process it first, and then come to the child decoder. So in this case, we're gonna jump to Windows date format, which is up here. This is a decoder that extracts the date format from the log file or the log entry. So pre-match, we can find pre-match here actually in every single decoder, here and here. It uses regular expression to extract or to match the logs. So let's go back to the one here, use on name true, and then we have pre-match, offset after parent, open, close, drop. So what does that mean? It means that this decoder will look for these words: open, close, drop. Now what happens if the decoder finds these words in the log entry? It will then process the regular expression. The regular expression will extract the data according to the regular expression itself. So here it extracts digits, strings, and words. And then we have the order. Now, what does the order mean? The order, it contains the list of names, okay? Names, you may also name them as fields to which the data extracted will be stored. So the data extracted from this regular expression will be stored in action. Likewise for the other values. So we have here a total of 6 values extracted from the log entry. They will be stored in these fields respectively. And then what happens when the rules are triggered, the rules will process these names and look for the values stored inside of them. Now let's take another one. This one is web access log IIS5. Looks like it extracts the logs from the Internet Information Server or the software used to host web servers on Windows operating system or Windows Server. Again, we have the parent, in this case it's Windows date format, to extract the timestamp. It is a web log specified as a web log, use on name, pre-match. So it will look for, as you can see, S++, it is for strings or any number of strings, and the word W3SVC. If it finds this word in the logs, okay, it will then process the next regular expression, and then the values extracted by this regular expression will be actually stored in these values respectively. You can again change these names according to your own preference, depending on the scenario. Now, what happens if, say, that the decoder doesn't find, or if the pre-match condition here is not satisfied? What's going to happen? The regular expression will not be processed, which means it will move on to the next decoder. That's how decoders work, and that's how they extract the data from the logs. So every rule starts with an ID. An ID is a unique identifier, and then we have the level. Now, rules have levels according to the severity of the rule. Levels actually range between 0 and 15, 0 and 12. You can find 0, 15, sorry. You can find the rule classification in the Wazuh documentation, where every level or every level is actually matched with its own description. For example, 2 is actually considered as low priority or informational or identification. Then we have if group. Now, if group specifies the group name, and then we have the field. The field name in this case is audit, and the type is PCR2 Python. So this is the field. okay, that is matched. What does that mean? It means when the information is extracted from the logs by the decoders, they will be grouped into field values, right? So what happens here, the rule will look for audit in the fields extracted by the decoder. If there is a match, it will then trigger the rule. The description says executed Python script. And then we have here, we can optionally have a MITRE tag where you actually assign an ID, a MITRE ID technique to the triggered alert. The next rule, the same, ID level 6 in this case. Let's go back to the rules, classifications, and we can see level 6 means low relevance attack. These indicate a worm or a virus that have no effect to the system, like code red or for Apache servers. These also include frequently IDS events and frequently error. So low relevance attack. Let's take a look here. So we see another regular expression matched against Python script execution. This one has level of 12. If we go to 12, so 12 mean high importance event. These include error or warning messages from the system. These may indicate an attack against specific application. Let's take a look here. So what is it trying to do? Now we have another tag here, which is if SID. If SID is actually a condition that specifies IDs of parent groups. So likewise, in decoders, where we actually mentioned the tag parent, where it actually here lists the name of the parent that should be processed first. Same here, we have SID. If SID lists the IDs of the rules that should be processed before the current one. In this case, we have 92600, this one, and 92601. I guess it is somewhere. Yeah, 601 is this one, I guess. So what does that mean? It means that this rule should first go back to these rules, right? Process them and then come back here. What is the match here? It is a regular expression that matches the execution of these two Python scripts. These Python scripts are responsible for SMB enumeration. So if they are executed, it means that there is a suspicious Python script matches impacket signature, possible use of stolen credentials or pass the hash attack. And we can assign them these MITRE IDs. So when this rule is triggered, there will be an alert generated in Wazuh with this description. Okay, so back to the same important point. When you first install Wazuh, all these rules will come actually installed by default. You don't have to install them yourself. Likewise for decoders. So having talked enough about decoders and rules, now we want to have a look at how we can test these rules using a practical interface or practical demonstration of Wazuh. For that purpose, I have found that the machine or the room custom alert rules in Wazuh perfectly fits the purpose of the scenario. Unfortunately, the room is not free. You need to be subscribed in order to deploy this room. So make sure subscribe, it's worth it, and deploy the room to practice the use of decoders and rules in Wazuh. So it's gonna take a bit to implement the attacker machine, but nevertheless, we're gonna take a look at the tasks and try to answer the questions. So task 2 is about decoders. We talked about decoders. I'm going just to see if any questions that can be answered. Looking at the sysmon log, what will the value of sysmon command line will be? So there is a log sample here. This is a log sample generated by system monitor. Thing is, sysmonitor logs are natively processed by Wazuh decoders. Specifically, this decoders or Windows decoders have section for parsing sysmon. logs. So this is a decoder. As you can see, we have a pre-match that looks for the word information, and if the word information is found, it's going to match this regular expression or process this regular expression that will look for the string Microsoft Windows sysmon / operational, and then any number of strings that come after it, and any number of digits. So here, this is the log that we have, and apparently it has the word information and the word Microsoft Windows sysmon operational, which means now the decoder here will match and extract the fields. So what happens next? Okay, so I have the machine ready now. Let's use the machine and go to the dashboard. I copy the IB here. So in the output here, we have this log entry processed using the decoder. And here we can see the output of this processing. It has two phases. The output can be broken down into two components. The first one is the pre-coding, and the phase 2 is completed decoding. Now the information is extracted in this phase. We can see the name, the parent, the data that was extracted, and other information such as the command line, the image, process ID, process queue ID. These are the information or the fields extracted by the decoder. Now what about pre-decoding? It's actually here the stage where first it ingests the logs or the log entry that we have supplied, and then extracts basic information such as the timestamp, the host name, the program name. So basically we can test this out using the GUI interface. If we go to Wazuh, click on advanced and accept the risk and continue. Let's first grab the username and password. What is the username? Come on. Yeah, so here the information are listed. So the username is Wazuh and this is the password. So the question is saying, what will be the value of sysmon command line will be? To find the value, we're gonna have to look at the extracted fields from phase 2 completed decoding. The command line value is this. It includes the path of the executable that was executed. And then we have what will be the extracted value, B, if the regular expression is set to user \s. So here, instead of using Microsoft Windows sysmon operational, we only use the user and any number of strings. We go back to the log here and we act as a decoder. We're going to look for the string user. So string user is first found here, okay, and then we have this which matches any string that comes after the word user. So user, and then we have this. This is the answer for this question. Now this is the Wazuh interface, and as you can see, the first thing we have to do is to add the agent. Again, I covered the process of adding the agents and integrating them with the Wazuh interface in the video that I put in the description. Now I'm going to go to Tools, Rule Set Test. The Rule Set Test is a tool that allows me to test decoders and rules that are actually installed with Wazuh. So we talked about the decoders here and the rules. If I want to test them, I can test them using the rule set test tool. But I have first to supply it with a log sample. In the case here, we have a log sample provided by this room in TryHackMe. We're gonna have a look at this log sample, paste it here. Now what's gonna happen, Wazuh will run this log against the decoders and the rules it has pre-installed, and it will give you an output. The output here, from the output we will be able to find out what kind of decoder that was used to extract the insights and what are the rules that were matched against this log entry. I'm gonna click on test, and we have, as you can see guys, we have around 3 phases. The first phase is the pre-decoding. Here we extract basic information such as the timestamp, the host name, and the program name. Next we have the completed decoding. The completed decoding here, it lists the data that were extracted by the decoders. Okay, you can see here what kind of information that were extracted. And let's keep scrolling down. In phase 3 we have completed filtering. Here we can see the rules that were triggered along with the ID of the rule. The ID of the rule here is 18.184.665. If we copy this and we search it in the Windows rules, let's look for Windows rules here. Windows rules. We have this monitor. Let's search here. None. Let's try to find it somewhere here. Windows. Okay. Unfortunately, they are not alphabetically ordered, so you're gonna have to keep scrolling until we find Windows Smarter Rules. Let's see here. No match of this ID. And no match for this. Okay, let me check here. See. So in the rules section, you can find that this is the rule ID. So it is sysmon rules. So sysmonitor rules. And let's look for this ID. And indeed, guys, we find the ID here. This is the ID of the rule that was triggered. So phase completed filtering, we can find the ID of the rule that was triggered. And scrolling down, you can see the level of the rule. It's a 0, and the description. It's a sysmon event. These are the groups that the rule is part of. That's how we test the rules and decoders. So circling back here to the task. Task 3, let's answer the questions. From the rule set, test results. What is the MITRE ID of rule ID 184.3.6? So we're gonna go back to the rule and see it is what? 184.3.6. I'm gonna look for this rule. And as you can see, the MITRE ID is T1055. That's one way of finding the answer. Alternate way, if you are doing the room, you can find the answer by going along with the room, taking this log file or this log entry. Gonna go back to rule set test, click on test, and we scroll down to see the triggered rule. With the triggered rule, we can see other information that come with the rule, which is the MITRE ID. According to Wazuh documentation, what is the description of the rule with a classification level of 12? We already covered the rule classifications. 12 corresponds to high importance events. In the rule set test page, change the value of sysmon image to task host and press the test button again. What is the ID of the rule that will get triggered? So in the log entry here, instead of service host, we're going to change this to task host. Test. And now we see the ID of the rule is now different. So 184.736. Rule order. We also talked about this. Rule order is the order of processing the rules. We said that when there is an FSID tag, an example is here. It means that the ID mentioned inside the FSID tag will be first processed as a parent rule, and then the current rule will be processed. The question here is sysmon rules XML file. What is the rule ID of the parent of 184.717? Let's look for these. So here we have this rule. Inside FSID tag, we have the ID of the rule that is the parent of this rule. Custom rules. Here you learn how to create custom rules. What is the regular expression field name used in local rules XML? So this is the local rules file. It is the file in Wazuh where you create your own custom rules. If you're not satisfied with the rules that come with Wazuh, you can create your own rules following the same syntax and the same method, using the same tags. The only thing different that you will do is creating different regular expressions. So here, what is the regular expression name used in local rules file? So do we have this file here? This is the local rules given in the room. And what is the field name? It is audit CWD. Looking at the log, what is the current working directory from where the command was executed? So here we have, do we have the log file or the log entry? Yeah, we have it here. Let's take it and go to the test tool. Now you can see the results of the decoders and the rules. So what's the current working directory from where the command was executed? So looking at the log file, we can see current working directory is var log audit. Fine-tuning here by adding more custom rules to a current rule file. If the file name in the logs is test, what rule ID will be triggered? So going back to the log here, this is local rules. Again, this is the file where you create your own custom rules. The question here is saying that if the file name is in the logs is test, what rule ID will be triggered? We're gonna have to look at the custom rules here and find the one that processes PHP files. So there is one here. It processes PHP files by extracting audit file name where the extension should be Python, Bash, ELF, or PHP. That's the rule ID that triggers these kind of files. If the file name in the logs is malware checker, what is the rule classification level in the generated alert? First, we're gonna have to find the rule that processes or matches this name. if we look closely, we can see that it is not this one, because this one, it matches the name of the file, but not the extension. If we scroll up, let's see here. So malware shell dropper, not this one, not this one. Audit file name malware shell dropper. It could be the one, malware, this one. It contains the string, so here it is level 12, and the level of the rule is 12. Okay, so that was it. Now there are more things to be covered regarding Wazuh SIEM, including the installation, the integration with other products. So the installation is so simple. You just have to execute a couple of commands to install Wazuh. And the other things that are important when using Wazuh, among which is the integration with different other products to enhance the threat intelligence and instant response capabilities. And also vulnerability scanning. We covered these aspects in the previous video, which you can find in the video description. So that was it, guys.